On the morning of Saturday, September 27th, 1970, some faulty power cables sparked some tinder, and close to Mountain Laguna in California, a terrible forest fire started. This would eventually be known as the Laguna Fire, and it was fairly devastating. At the time, it was the third largest forest fire ever recorded in California, and it spread more than 30 miles in only 24 hours. That's almost as quick as people walk, right? And it had tremendous impact on the state. More than 175,000 acres of woodland was destroyed. 382 people's homes were burnt to the ground, and 16 people lost their lives, not to mention the countless number that were sent to hospitals. But the fire season of 1970 was not just the Laguna Fire. It was an all-time historic, terrible fire season. In total, more than 576,000 acres of woodland burnt to the ground. 722 commercial and residential buildings ceased existing. And about $1.5 billion in damages was assessed for this. My name is Alex Hidalgo, and I'm here to talk to you about the incident command system and how we can better respond to emergencies by using the knowledge that's come before us. So the 1970 California fire season was one of the worst on record. And many things made this happen because changes cause other changes, and changes can impact everything. And during the 1960s, there were a bunch of changes. California passed some new land use legislations, which resulted in the expansion of both commercial and residential and industrial enterprises into some of these areas that were previously just woodlands. And in 1964, the federal government passed the Wilderness Act, which was actually a great move for our ecology. But one of the things this act did was it instituted new response measures for forest fires. The basic research was that forest fires are actually a natural part of the ecology, and they need to happen for environments to stay normal and healthy. So part of what this act did was it said, well, instead of extinguishing fires being our primary purpose when they happen, we should just be containing them and allowing them to burn a certain amount. And this is well-intentioned, but when forest fires are being caused by human reasons in addition to natural ones, you might see where some of these problems are leading to. And finally, we had a growing population. Southern California was growing very quickly at this time. And just with more people involved, there was a greater chance of people being impacted by these things. So it wasn't just that the forest fires were necessarily larger, it's that there were more people around to be impacted by them. Changes emit other changes. And a lot of things led up to 1970 being an all-time historically bad fire season. But I want to take you on a tangent real quick, because while I was doing research for this talk, I was reminded of this other really interesting ecological story. In 1926, the last gray wolf in Yellowstone Park was shot and killed, bringing the population down to 0. And this is how things were for decades and decades. But the lack of having gray wolves in Yellowstone Park had changes and impacts that people didn't quite expect. So without any gray wolves, we were in a situation where herds of elk that live in Yellowstone stopped moving around as much. Traditionally, just to stay away from their predators, elk would eat a little bit here, move on, eat a little bit here, move on. Since the elk felt safer, they suddenly started staying in the same place. So instead of eating a bit of these various willow plants and trees, they'd eat them all the way down to the ground. And that meant that the beavers in Yellowstone Park didn't have the supplies they needed to build their dams and their dens. And this was true up until Thursday, January 12th, 1995, when a group of 8 gray wolves were reintroduced to Yellowstone. I believe it was 12 more were reintroduced a few weeks later. And very quickly, the gray wolf population rebounded and settled back into a natural state. And with the gray wolves back in Yellowstone, suddenly the elks were more likely to migrate across the park and move to different areas. And this meant they were no longer chomping down on these individual willow trees to the point that they didn't exist. And this meant that suddenly the beaver populations, which at that point in time had fallen to just a single colony, were able to rebound themselves because they had the supplies they needed to survive. And we can even take this one step further, because even though more wolves meant there were now more beavers, I believe within a few years or up to 8 colonies from one, this also meant that there were actual watershed changes, because beavers impact the environment at a very high level. Not just did the watershed change, the actual directions that streams and rivers within Yellowstone took changed paths. This is really cool to Google and find images of what before and after looked like. But let's get back to forest fires. The point is just that changes that you think may end up with one outcome often end up with a different outcome, because changes emit other changes. So not only was there new land use legislations and the Wilderness Act in 1964 and the general growing population, but because of all these things, because more people were being impacted and there were more cities and towns around, this meant there were more responding agencies to this. And this meant there were more groups involved. And this meant that they had to figure out how to fight these fires together. So in the fall of 1970, there was a meeting because the various responding firefighting departments in Southern California acknowledged we did not do a good job this fire season. We believe we had the resources, but why were these fires so bad? Why were we so bad at containing them? And so they had a series of meetings and they figured out a lot of stuff. The reports for this are numerous and lengthy. But the primary takeaways is that the communication was bad. When you don't have a shared terminology or a shared vocabulary, it's difficult to coordinate with other people properly. When you approach problems differently, when each of these agencies have their own containment techniques and their own ways of trying to respond to these incidents, that makes it more difficult to be efficient. And when you have different organizational structures, it can also be difficult to know, who do I talk to on that other team? Who's in charge of this thing? On our team, it's someone with this title, but on that team, it's someone with that title. All of these things can be encapsulated as being part of poor communications. Different groups, different agencies, different responders to these incidents, to these emergencies, they couldn't communicate correctly with each other. So, partially because of these findings, the 92nd Congress of the US in 1971 passed a bill to give a whole bunch of funding to a group that was eventually called FIRESCOPE. And FIRESCOPE stands for Firefighting Resources of Southern California Organized for Potential Emergencies. And this was a working group that existed for years and years. This wasn't just a single summit. Real research commenced. Academics were brought in. Data from all over the world was analyzed. And there were studies and research and more studies and collaboration with other academics and lots of feedback, and there's peer review, and this went on for a very long time. They were taking everything that they could possibly get about how to respond to forest fires or incidents in general, and how can we fix these problems we have, that when you have multiple groups, how can we ensure that the communication works, and how can we make sure that our responses are efficient? So after all this research, they kind of came up with a whole bunch of conclusions. If you want to go read these reports, they're all, like you can find them online. But from my perspective, there were about 4 real main things that they were trying to address here. And one, they wanted some kind of formalized communications. What are our channels? What is the language we're going to use? Who do we contact? Which falls into the next category, formalized hierarchies. Who's in charge of what and where for all these different groups? Who should we be contacting if we need to relay some amount of data? A formalized response, basically saying if we are all trying to approach the problem in a different way, that might actually be less efficient than even if we're all using a slightly less efficient process. If everyone's aligned, you can get more done. You can share your resources better that way, because everyone's going to use the resources in the same way. And finally, they wanted to eliminate freelancing. There was too much of a problem of certain agencies or certain groups or sometimes even certain individuals going out and taking things into their own hands. And it's a problem when someone's trying to solve a problem and you don't know what they're doing. Everyone needs to be on the same page, otherwise you're not really working together. And this research continued for many, many, many years. This was not a quick solution. This is not something that ended, after a few meetings. And it wasn't until the fire season in 1978 that some of these findings were used in the real world. And this is the first time the Incident Command System, or the ICS, was used to actually respond to forest fires in Southern California. And it was considered a success. The Incident Command System appeared to use resources better, respond to incidents better, contain fires better, cause less property damage. There were almost no deaths that year. And so because it was such a success, people realized maybe we can use this for things that aren't just forest fires. So first it grew to be used outside of Southern California and moved to a whole bunch of other forest fighting agencies and the US Forest Service in general. And then by 1980, it was also being used for hazmat situations. And eventually, as the 80s progressed, it kind of became the de facto way to respond to all natural disasters, whether they were hurricanes or earthquakes, and even things like urban search and rescue, building collapses, and unfortunately things like terrorist attacks. These were all things where the Incident Command System was found to be incredibly useful to help for a unified response. And this proceeded all the way up to Monday, November 25th, 2002, when the Department of Homeland Security said, this is now mandatory. If you are an emergency responding organization within the United States, you must use the Incident Command System. And this is everything from major hurricanes requiring thousands and thousands of people down to any situation where a small police department and a small fire department in a small town may have to coordinate with each other. This is now federally mandated. But after all that, you may be saying, why do I care about this? Why do I care about the history of the Incident Command System? And it's because it can be useful for your computer systems too. And one of the reasons why is because I think we're at a really cool time in our industry where, so tech, I think, has had a problem for decades where we want to solve problems ourselves. We kind of assume that the things we're running into are new because they involve computers, because they involve software, when really a lot of what we're trying to solve has already been solved by experts in other fields first. Because almost nothing we deal with is actually new. Engineers have been dealing with how to make things reliable for as long as humans have been building things. When you build a bridge, even if it was thousands and thousands of years ago, you want to make sure you built it correctly so that people can walk over that bridge and it doesn't collapse. There are many models that have been developed by engineers over thousands of years that we can adopt to make our own services more reliable. When we're analyzing data, we often try to find new approaches and new maths, but statistics is a centuries-old discipline, and there are many models and formulas that have been developed over the years we can just use. But what I want to focus the rest of this talk on is the ICS, the Incident Command System, because it is something that has been in existence for decades. People have been researching it for decades. There are academics that have spent almost their entire life basically researching this and talking about it, and it's something we can use too. And while the ICS addresses many problems, the four that I think it addresses that are probably most relevant for you, the current audience, are the following. The ICS makes sure you don't have a lack of insight. It makes sure that anyone can find out what is currently happening and what has happened. It takes care of poor communication. It makes sure that people know how to communicate with each other during an incident and who to communicate with. It makes sure that there is an established hierarchy, which is important when you're dealing with an emergency. You need to know who's in charge and who's making the decisions. And finally, it takes care of the problem of people freelancing. There's almost nothing, in my opinion, more dangerous than multiple people making changes to a production system at the same time, especially when they don't know what the other people are doing. So we can't just adopt the ICS. It is massive. It has gotten very complicated because dealing with a major earthquake or a hurricane or a forest fire requires sometimes thousands and thousands of people. Chances are for our computer software related incidents, we don't have that many people involved. So I'm only proposing we take some of the philosophies of the ICS, not necessarily the ICS itself. So how can you do that? Before I get into my example, I just want to say this is one example. This is a version that I've been teaching teams and organizations that I've used at multiple companies that works well, but it works well for me and it works well for my situations. So even as I get into this example, and I do think it's a good example of how to use the ICS, I do want to be clear, it's the philosophies of the ICS, how to make communication better, how to stop freelancing, Those are the important parts. So at the end of the day, do what works best for you and your situation. But here, I present an easy and effective use of the incident command system for computer things. The one important part that I do think you need no matter what, no matter how you choose to implement this, is you need an incident commander. The incident commander is someone who is in charge of the entire incident and likely has the most state. They are the ones in charge of choosing who is doing what, and they're the only role that actually has to exist, in my opinion. People are going to differ on this, but I think that if you get a page, you are now the incident commander. And maybe you don't delegate to anyone else, and you don't need to use the ICS any more than that, but that's where it starts. You are the incident commander. The incident commander always exists for any incident, no matter how small it is. But the incident commander is also someone who can delegate things out to other people if the incident turns out to be larger. That being said, every role that I'm about to describe, some of the useful roles that I think exist for computer systems, you should assume the incident commander is that role unless it's been delegated. But even though the incident commander is generally in charge, it's a role that can and maybe should be handed off to other people. And we'll get into details why in just a moment. One of the most common other roles that you will see the incident commander delegate out to is an operations lead. So an operations lead is just the person making production changes to your system to try to mitigate or even resolve the incident that you're currently experiencing. As we just said, there's almost nothing more problematic when trying to respond to something than having multiple people trying to make changes to the same system at the same time. So the purpose of an operations lead is to have a single person who's responsible for making those changes. And as I just said, you can often hand off the role of an incident commander. And one of the ways that this works best is that often the operations lead is actually the person that first got the page. So even if I'm telling you that as soon as you get a page, you are the incident commander, you often start digging into the problem. So you probably know best about what needs to happen next. So you should just become the operations lead. So what you do is you tap someone else in. You say, hi, I need help. You need to be the incident commander for me. Run this incident. I will keep making production changes. These changes should be documented. You need to make sure that everyone knows what you're doing and when. I would say this even drills down to actually pasting individual commands that you're running. And one of the most important parts here is this is a role that needs to be delegated. You can't just declare yourself, I'm now operations lead for this. You can offer. There's nothing wrong with that. If you know something's going on and you're watching the situation, you can say, hi, I'm available, I'm willing, I'm ready, I'm able. Do you want me to be the operations lead? But you are not unless the incident commander says you are. One of the things that's very important in order for this kind of double setup with an incident commander and operations leads, you need to have some kind of command post. And a command post for computer reasons is generally just like a Slack channel or some kind of chat. But it needs to be discoverable. It needs to be a single place that all stakeholders know they can go to find out what is currently happening. And I really don't have much of an opinion about whether or not it's better to have a single war room channel you use for every single incident, or if you create a new channel for every single incident, right? There's a lot of vendors and tooling out there that will like automatically do this for you and create a new channel and start a history and all that. I'm not sure which one's better. Again, do whatever's better for you. The important part is it documented and is it discoverable? Can people find out where is this discussion taking place? I do believe, however, text is much preferred over voice communications here. Asking people to join a voice bridge or a phone call, this is confusing for people. People talk over each other. You don't have a history. Anyone can join a chat room and read what was said 5 minutes ago. You can't just join some kind of call bridge and find out what was said 5 minutes ago. So I do think text is better. You can also, just copy and paste stuff out of it for further analysis and things like that. But although part of the reason this channel should be widely distributed and very discoverable is anyone that cares, any stakeholder, should be able to follow along, the incident commander should feel free to police this as heavily as possible. If there's too much cross chatter, if there are people pushing graphs because they think it's going to help, the incident commander should feel free to say, hey, stop, we need this channel for coordination. In fact, if you want to make it read-only for most people, I don't think that's necessarily a bad approach. The next most common role that I think is often useful in using this kind of system is a communications lead. And the communications lead is just someone who's responsible for performing all the communications. If the incident commander is too busy to handle this themselves, as might be with a very large-scale incident, you appoint a communications lead. And this is the person who's communicating both internally and externally with your customers or your internal users, with custops, and even up to leadership and the C-level, whoever might be involved in a large-scale incident. They're the ones doing the communicating. And this is because it's just as important as having only one person making production changes. You only want one person communicating things out. Otherwise, the messages can get muddled and confused. Like, imagine two people trying to update the status page at the same time because you haven't agreed on who's going to do that. This is why you might need a communications lead. And this might also be a good person to keep up what I call an incident state document. We'll get more into what that is in just 1 second. But just like the operations lead, the communications lead is something that needs to be delegated. It's not something you can just become. Again, if you want to offer, if you want to say, I'm here, I'm ready, I'm willing, I'm able to be the communications lead, that's fine, but you are not until the incident commander says you are now in charge of all of our communications. So to talk a little more about incident state documents, they're just a centralized place to kind of dump relevant data. So people don't have to read a bunch of scroll back that you have in your command post or your war room or whatever, and people can find out where are we currently. One of the most important parts of an incident state document is actually who is currently occupying what role. If we're going to place importance on we need an incident commander, we need an operations lead, we need a communications lead, people need to be able to find out who those people are. So that's one of the primary things that goes in here. Probably also want to document what's happened, what you think the future steps are going to be, all that kind of stuff. And this is where templates are really good because you don't want someone to forget about something that needs to go into the incident state document. But to be totally fair, an incident state document doesn't even have to be a document. There are plenty, again, vendors and tools out there that do this kind of stuff for you, and that's fine. The point is just that you need certain things to be discoverable by everybody. So make it discoverable in some way. A neat hack, by the way, that someone taught me the other day, if you are using Google Docs, if you add /copy to the end of the URL, if someone visits that link, they'll automatically be prompted to just create a copy of that template. It's really cool. It's very simple, but it's a really cool way to ensure you can provide a single link that persists for all time that people can just click on, and now they have a new copy of the template over and over and over again. Use this for everything. It's a really cool little hack. And the final role that I often find useful in large-scale incidents is the planning lead. And the planning lead is a bit more ambiguous. They're really just there to support the other leads. There's someone designated to try to make sure that the incident commander and the operations lead and the communications lead are all, that they're doing okay, that they have the resources they need. And while the other leads maybe focus on the immediate, the planning lead may be focused on the future. And this can involve everything from proactively filing tickets for follow-up items, all the way down to like finding new engineers. Because at some point in time, if something's long running, you're going to have to hand off. Humans can only pay attention and focus correctly on things for so long. So a planning lead might do something like, hi, are you available to take over in half an hour? Can you start catching up now? Because you're going to have to be the new operations lead or the new incident commander. And even further than that, the planning lead might be responsible for things like ordering pizza for the engineers. Right? If you are stuck just working on a problem and you can't leave the office and you can't even leave your desk for a minute, you might need some food, you might need some coffee. Designate someone to do that for people. It's not that difficult. It's a thing people just don't think about. But make sure that a planning lead is in place if you're dealing with something long-running and large. But just like everything else, the planning lead is delegated. As I've said before, you're more than welcome to volunteer. Say, I'm ready, I'm willing, I'm able to do this, but until the incident commander tells you that you are the planning lead, you are not. And one of the cool parts about the incident command system is just how flexible it is. It was inherently designed to expand and contract as needed. It was originally designed for forest fires. And how can we handle the communications across many different responding agencies? And sometimes you might say, hey, this fire's bad, we need more help. And more fire departments would come in, and the Forest Service would bring in more people, but then you have it more under control, so then some of those people can go home. And that's part of how this works. This is part of why it's a good system. You only involve as many people as you currently need. And the other way that, again, things are flexible, it's mostly a philosophy that you should be adopting. So don't just listen to me. Think about the concepts I'm talking about. Maybe you don't need a planning lead in your organization, or maybe you don't want to use the term operations lead or whatever. That's all fine. The point is, make sure you're focusing on, are we communicating properly, and can we communicate across teams and across many individuals? And one of the other ways that the ICS is flexible, the way it can expand, is let's focus for a second on what it might look like to expand the operations lead role. So we have our basic setup here with an incident commander, an operations lead, a communications lead, a planning lead. But one of the most common places that I see this kind of expansion is within the operations lead section. So while the operations lead is still responsible for all production changes actually happening, it's not uncommon for them to designate a databases lead, because that's often a place that has some amount of domain expertise, and maybe you need someone that knows databases well to ensure they're running the right commands on those servers or with those systems. Something else you often see is a networking lead. Again, this is an area that often has specific domain expertise required. In fact, a lot of organizations, engineers can't even log into all the networking devices. So it may make sense for the operations lead to be like, okay, I'm doing this stuff, but you do the databases stuff, and you do the networking stuff. But if an incident is very large, maybe it goes even larger than that. Maybe the operations lead actually stops running any commands in production at all. Maybe they stop making any production changes, and they're just coordinating. Here's what's happening with databases. Here's what's happening with networking. Here's what's happening on the systems. Here's what's happening with the services. And at that point in time, they may operate as only kind of a liaison in between the incident commander and the people running the actual commands. And this is just one example. Again, make this work for you. As I mentioned earlier, make sure you also have a built-in system for handing off. It's not even a bad idea to say after 6 hours or after 4 hours, right? It's not a bad idea to have these scheduled handoffs, because it can actually be very psychologically affirming for people to know, I only have 45 more minutes left of this, and then someone else is taking over. In a talk I gave at SRECon just a few weeks ago, one of the things I talked about was having a 37-hour-long incident, and we needed someone involved at all points in time. Every single member of my team acted as an incident commander at some point in time during those 37 hours. We had handoff after handoff after handoff. And handoff is not really complicated. You just take whatever role it is, and here I have the incident commander role, and you say whatever hats they're currently wearing, whatever things they're currently responsible for, second person comes in, the first one steps aside, the second person takes on. This is why having a good incident state document helps, because it can get someone up to speed very quickly. And then that second person can take over, and the first person can go to sleep, or get something to eat, or just leave the office. Now, this all may sound heavyweight when I'm telling you that, in my opinion, you have an incident commander as soon as someone's paged. I think that's the right place to start, because that way you know you can put this framework into place quickly. But how do you know you have an incident? How do you know if you need to use the system? I think it's actually pretty simple, because if you're asking the question, you probably should. It's much easier to backtrack and say, you know what, that wasn't that bad. I'm glad we didn't involve too many people. That's much easier to do than to be 3 hours into something, suddenly realize, oh shit, this is much bigger than I thought, and then somehow attempt to put this framework into place. So if you're wondering, is this an incident? Do I need to use the ICS? Yes, start there. Make that your starting point. And the other thing that's important here is that you need to make sure that you're building a culture that understands things break. One of the most common reasons I see of people, even when they work in organizations or on teams that say, yes, we use the ICS for all of our incidents, is that people are afraid to declare an incident. Because declaring an incident means that there's a mandatory retrospective or post-mortem, and it probably means that directors or VPs are aware of this thing happening, and sometimes people are kind of scared of that. Do your best to build a culture where people understand stuff breaks. Nothing is ever 100% reliable. That's not how the real world works. At some point in time, you're going to have to deal with some kind of incident. And that's fine. Make sure people are all on board with that, and that makes them more likely to say, yes, I need to be using the ICS right now. I need an incident commander while I take over as operations lead because I'm the one that has been responding so far. That's totally fine. Stuff breaks. And this is a good idea because the ICS works. We have decades and decades of data about this. Well, mostly. Sometimes it breaks down. In 2005, Hurricane Katrina hit the southern coast of the US. One of the most devastating natural disasters to have ever occurred in this country. About 80% of the city of New Orleans was flooded. More than 1,800 people died. There's more than $125 billion of damage. I was just in New Orleans this summer after I knew I was giving this talk. And so I spent so much time talking to locals and asking them, what was it like? It is a thing everyone there still thinks about every single day. It was a massive, massive catastrophe. And I believe rightly, the response to that was widely mocked. About 6 months after Hurricane Katrina, FEMA produced this report. It's fairly lengthy. If you include all the appendices, it's about 300-something pages long. And in this report, though, I think it's page 3 or 4, there's a pretty telling quote. I'm going to read directly. The federal government, in particular the Federal Emergency Management Agency, or FEMA, received widespread criticism for a slow and ineffective response to Hurricane Katrina. Much of the criticism is warranted. The responding agency themselves said, we fucked this one up. And lots of things went wrong. A natural disaster is difficult. No one is saying FEMA could have saved every life, or they definitely couldn't have stopped New Orleans from flooding in the first place. But they didn't do things well. They messed some things up. And although the report actually outlines 38 different concrete steps that they believe need to be taken to ensure that this bad of a response doesn't happen again, the three most important here, I think, is that they realized they did not anticipate, they did not train their people, and they didn't test their systems. So if you're thinking about adopting the ICS to respond to your incidents, make sure you're doing things like anticipate. No one thought a hurricane of that size and strength would hit at that exact location. It wasn't a thing enough people thought about, so they weren't ready for it. So make sure you are thinking about ways your systems can fail. That's how you're resilient. You need to have a plan. So make sure that your version of the ICS is documented and ready to go. And the only way it can be ready to go is if your people are trained on it. So make sure you develop workshops and trainings, not just documentation. You can't expect everyone to just go read a 20-page document about how your organization is going to use the ICS. You want to make sure that you are actually sitting down in a room and running people through all this. Make sure you provide tooling and templates like we were talking about earlier. Make it easier to use the system. Don't make everything manual. There's ways you can automate even the human processes of using the ICS. And you need to make sure you're conducting meaningful introspectives or retrospectives or postmortems, right? You want to make sure that you're learning from the incidents that have happened before you. That's the only way you build resilient systems. And finally, test things. Run workshops. Do chaos engineering. Do a black hole of one of your data centers. Make sure you're doing things to actually put this system into practice, even when things are not actually broken and are not actually wrong, because operational underload can be as dangerous as operational overload. People forget how to fix things when they don't have to fix them. So have people fix them every once in a while, even if nothing is broken. So conclusions, the primary points, have an incident commander. It's a good idea to have a single person in charge. Make sure that all roles are delegated and documented. Make sure everyone's on the same page. Make sure everyone knows who is doing what and when. Make sure you have a centralized command post. Make sure everyone knows where they need to go to find out about what is currently happening. Make sure you have some kind of incident state. It doesn't matter if it's a document or you're using tools, but stakeholders need to be able to go somewhere and find out where are we currently and who is currently doing what. Make sure that you expand or contract at will. If you think you need to page someone, page them. They can disengage. That's fine. It's better to be safe than sorry. Make sure you're handing off regularly. Don't put too much stress on any individual people. And test and train people on these processes and procedure. You can't just put them into place and have an RFC or a design doc that's been approved and say, okay, cool, we're done now. So use the ICS because mostly the ICS works. Thank you.
So I'm happy to say we have 5 minutes for questions. If you could walk up to the microphone, super important. We want to make sure that we get your question so it can be recorded later, and questions only. State your question.
So actually, as part of my day job, I'm a communications unit leader for emergency management. One of the things, how do you handle the handoff between incident commanders in this model so thus Steve is not getting paged at 2 in the morning when Steve's not the incident commander at the time?
Yeah, so there's 2 different things there that I think are important. Is one, that's why you have a planning lead. You have someone who 30 minutes beforehand pages Steve at 2 o'clock or at 1:30 in the morning and says, we need you ready to take over at 2 o'clock in the morning. So that's the first thing, is just be proactive and make sure you have someone in charge, because the incident commander is likely to focus on the incident. The planning lead can be someone to say, hey, I'm finding you someone who's going to take over for you in 30 minutes. That also that doesn't just allow that person to get up to speed, it allows the incident commander themselves to get ready to wind down, to get ready to be like, here's exactly what I need to tell this next person so they can take over. So I think those are the most important parts there.
Hey, my name is Maddie. I have a question on incident commander role. So I've been an incident commander for a fairly large outage, and I struggled a lot with blackout of information, like not being able to go to my monitoring system and interactively debug stuff, but telling other people to do that kind of created this mental gap of, hey, where are we right now? Do you have any advice on how incident commanders could avoid that kind of problem?
There are 2 things there. So the question was basically like, how do you as an incident commander feel comfortable stepping back and not do the debugging yourself? One, you can. It's fine for you also to go as long as you're not making changes, right? That's why you have an operations lead, for example. But there's nothing saying just because you're the incident commander and it's more important for someone to go look at a dashboard, doesn't mean you can't as well. Your input is valued. Running the ICS and being the incident commander almost implies to a sense that you are trusted to make these decisions. So if you want to go look at data, that's fine. And in fact, I'd say basically anyone involved can look at the data as long as you know who's actually doing things, who's actually changing things. So that's the first part, is I think it is okay as the incident commander to go and try to help debug a bit as long as you're leaving the things that have been strongly delegated to other people to those people. The other thing though, trust. Do this over time. If you're really in a situation where as the incident commander, you don't have the time to go look at these graphs, if you've done this enough and you trust the engineers who you're instructing to do so, you won't feel that same kind of pull. You won't feel that kind of like, oh God, I need to know this. No, because you trust the people who are doing the actual troubleshooting.
With that, I want to have everyone give a round of applause to Alex Stauge.